Hey everyone, we're going to continue what we were working on in the last video. We're going to continue working on finding the limit as x approaches infinity. So if you practice some, great. If not, you might want to, but we're going to keep doing a couple more examples. So if you recall, we talked about taking the limit as x goes to infinity, which sometimes requires some algebra. In this case, we need some algebra because on top and bottom of our fraction, we have x's. So the trick that we discussed in the last video is to multiply top and bottom by 1 over a power of x. Do you remember what power of x we talked about? The highest power in the denominator. So in this case, that's the x squared here. So 1 over x squared is what we're going to multiply top and bottom by. So remember to keep your limit notation, don't lose that, as x goes to infinity. And we're going to distribute 1 over x squared multiplies by every term on top and every term on the bottom. So 3x to the fourth divided by x squared leaves you with 3x squared plus x squared divided by x squared is going to just leave us with a 1, a placeholder, minus 3 over x squared. And there's the top. On the bottom, we'll divide each one by x squared. So 2x squared divided by x squared leaves the 2. X divided by x squared leaves us with 1 over x minus 4 divided by x squared. So just like we did in the last video, we're going to take the limit of the top separate from the limit of the bottom, and then we're going to look at each term individually. So if we let the first term, x, go to infinity, so infinity squared is infinity, times 3 is still infinity. So this whole piece right here is infinity. So our limit is equal to infinity plus the limit of 1 being a constant, stays the same, so that's 1, minus 3 over x squared. What is this fraction going to do as the denominator goes to infinity? The whole thing is going to go to 0. So minus 0 on top. Divide all that by the bottom. So 2 is a constant, so the limit of a constant is the constant, plus what happens as x goes to infinity to 1 over x? 1 over infinity. Remember, it's when we discussed a finite number divided by infinity, all of that goes to 0. And the last term here is also the same situation. 4 over x squared. So 4 over infinity, the whole thing goes to 0. So minus another 0. So what does that mean we end up with? Well, infinity plus 1, still infinity, minus 0, still infinity. On the bottom, we have 2 plus 0 minus 0, so that's 2. If you take infinitely much, divide by 2. For example, if a billionaire were to pass away and he had 2 children, they'd split the inheritance. Those 2 children would still have a lot of money. So if you take infinity, divide by 2, we still have a lot, a big number, infinity. So what does this mean? As x goes to infinity, this function's limit doesn't exist. This function blows up. It goes huge. So we're not approaching a horizontal asymptote in this problem. So in this case, we would say that there is no horizontal asymptote. Remember, when you're talking about x approaching infinity, you're talking about the ends of your function and what it's doing. Is it approaching a value? That value would be your horizontal asymptote. So we've done a couple examples. And I want to go back and I want to summarize them as a way for you to check your work. On your exams, showing your work, I expect you to do this. I expect you to multiply by the 1 over x squared and find the limit. However, you can check your work by using an old trick that we used to have. To find a horizontal asymptote, there are basically 3 cases for us. Number 1. Which one do we do first? Let's do the one we just talked about first. If the top degree, the highest power of x, so in this case that was x to the fourth, is greater than the bottom degree, which is the case we just did, what does this function have in terms of a horizontal asymptote? We just found out there's no horizontal asymptote. Why? Because the top blows up faster than the bottom, so therefore the whole thing ends up blowing up to infinity. Number 2, what if the top degree is equal to the bottom degree? This was one of the previous problems that we did. Go back and look at your notes. If the 2 degrees are the same, there is a horizontal asymptote, and it's at y equals the coefficients of the leading term on top dividing by the coefficients of the leading term on bottom. So if we go back, I have the problem right here, scroll up. In part C, we had x squared and x squared were our two highest powers. Those were our leading terms, so the degrees are the same. So the coefficients 5/3 was the limit. That was the horizontal asymptote. One more case that we talked about. What if the top degree is less than the bottom degree? Well, that means that the bottom gets bigger, bigger, bigger faster than the top degree. So we saw that in finding the limit in this case. I should go back and show you which problem. We found that the horizontal asymptote was at y equals 0. So that one was D, where the top degree is less than the bottom degree. So this was a 1 and a 3, the degrees, and that is why the horizontal asymptote went to 0. So those are the basic ones when you have just a basic rational function, but we also have some other cases we can talk about involving roots. These are some fun problems here. I know that's always scary when your professor says these are fun problems, but they are. I enjoy them. So we want to use the same trick. The problem is we have a cube root in the way. So how do we do this? Well, what we're going to do is we're going to work with the root. We're going to go ahead and put a root on what we're going to multiply by. So we're going to use the same trick we used before. We're going to multiply top and bottom by 1 over the highest power of x. So that's x to the 4th here. But because our original problem has a cube root, we're going to put that cube root on what we're multiplying, because when you multiply cube roots together, you multiply the insides together. So if I do 1 over x to the 4th and 1 over x to the 4th, now I can distribute my fraction inside of the root to each term. So don't forget to keep your limit notation until you actually take the limit. And we have here the cube root of. So the cube roots stay because we're multiplying the insides together. So 7x to the 4th divided by x to the 4th, that would be 7, minus 2 divided by x to the 4th, all over, let's see, 5x to the 4th divided by x to the 4th, that would be 5, plus 2 over x to the 4th. Okay, so we know from our limit rules that we can bring the limit inside of the root, and we can take the limit of the top and the bottom separate, and then each term. So just go inside, take the limit of each term. So the limit of 7, a constant, is just going to be the 7. Don't forget to keep your root. So 7 minus, what happens to 2 over x to the 4th as x goes to infinity? That goes to 0. Finite number divided by infinity. Same thing on the bottom. 2 over x minus 4th goes to 0. So we end up on the bottom of 5 plus 0. So the answer here is the cube root of 7 over 5. Could you have gotten that from the beginning? Yeah. The rules do work for the cube roots, but I expect you to show your work on your exam. Show me that you can take the limit. The only reason we have those rules is because somebody figured out how to take the limit. So yes, you can use the rules to check your work, but make sure that you know how to do it, because I will be watching for you to show me how you take the limit. All right, one more example here. This one's a little different because we only have the root on part of our problem. So what are we going to do? Well, we're still going to do basically the same thing, but we're going to do one at a time, top and bottom separate. So where do we choose our x power from? The bottom. So let's start there. So on the bottom, we have a square root, so we need a square root on the bottom. The highest power of x here is x squared, so we're going to do 1 over x squared. What is the square root of 1 over x squared, though? Well, the square root of a fraction is the square root of the top and the square root of the bottom. So the square root of 1 is 1, and the square root of x squared is x. These two are equal. So instead of putting the square root of x squared on top and bottom, we're going to put its equal counterpart, its algebraic equivalent, 1 over x. So all we did was simplify and put the simplified version on top. Why did we do that? There's no square root on top. So we don't want to complicate our problem. We want to simplify it. So we don't have a square root. We don't want to create one because that's going to complicate it. We want to work with what we have. No square root, so let's try and work with no square root. All right, let's see what we get. The limit as x goes to infinity of, all right, on top, let's distribute here. So we're going to distribute 1 over x on top And we're going to distribute 1 over x squared inside the square root on the bottom. So x divided by x is 1. 3 divided by x can't be simplified. Square root on the bottom, don't forget that. 6x squared divided by x squared, that's 6. Minus 5 divided by x squared. Take the limit. Do the limit of the top and bottom separate. Bring the limit inside the square root. Do the limit of each term. And let's see if we get an answer here. So the answer is limit of 1. That's a constant, so that's 1. The limit of 3 over infinity, that goes to 0. 5 over x squared also goes to 0. So we end up with 1 over the square, don't forget that square root of 6. If you want to rationalize, you can. You would multiply by what? Do you remember what to multiply by? The goal is to get rid of the square root. If you can take the square root of 6, do it, but this number we can't. So multiply top and bottom by the square root you want to get rid of. On top, you end up with that square root. On the bottom, you multiply them together. The square root times itself cancels out the root, and you end up with just 6. You have to pay attention in your homework system and make sure which one they accept. They might accept both. They might be particular. Did they ask you to give the rationalized answer? Well, those are your examples of how to find the limit. Yep, that's my last one. So study hard, practice. These require practice. Make sure you practice. Don't just use the shortcut. Find the algebra manipulation so that you can make things go to 0. Good luck, have fun, I'll see you in the next video.